Welcome back to Easy Academic. In this video, in the linear algebra series, we'll be discussing matrices in linear algebra. So first, we must discuss the concept of size of a matrix. So matrix size is often denoted m by n, where m is the number of rows in the matrix, and n is the number of columns. So for example, let's say we have a matrix A, which is 2 by 3. That's its size. And we can describe A, for example, as the matrix 1, 0, 4, 5, negative 2, 7. There are 2 rows and 3 columns. Hence, it's 2 by 3. Similarly, let's say we have a matrix B, which is 3 by 1. Let's say this matrix is 6, negative 2, 3. You might notice that this is a column vector, which we can use to demonstrate a vector in 3 dimensions. But once again, there are 3 rows and 1 column. This begs the question, how do we refer to each individual entry in the matrices? So let's take the example of matrix A above and just rewrite it down here. So matrix A equals 1, 0, 4, 5, negative 2, 7. Let's say we want to refer to the element, this element right here. Well, the way we do that is we say lowercase a, and we refer to the item in the ith row in the jth column. So in this situation, the number 4 is in the first row. It's in the first row, and it's in the second column. So let's say we're referring to A1, 2. This would be 4. Similarly, if we were referring to, let's say, the item in the second row, third column, so A2, 3, we would find the second row, third column, and see that we're referring to 7. Now, the topic of matrices introduces the idea of some special matrices. So the first special matrix we'll be walking through is the zero matrix. So this is a matrix with m rows and n columns. The dimension is sort of arbitrary, but the zero matrix is any m by n matrix where all of its entries are 0. So let's take, for example, the 2 by 3 zero matrix. There's only one zero matrix for the 2 by 3 dimensionality. And so we say the 2 by 3 zero matrix is equal to 0, 0, 0, 0, 0, 0. And that's a matrix where every entry is 0 with 2 rows and 3 columns. Let's take the second special matrix, which is the identity matrix. Now, unlike the zero matrix, there is a condition on the dimensionality of the identity matrix, and that is it must be n by n. So that means the number of rows has to equal the number of columns. This gives it the property that it's a square matrix, and on top of that, all of the entries along the top left to bottom right diagonal are all 1s. So let's take, for example, the 3 by 3 identity matrix, which is often denoted as I, or sometimes as 1. And we'll say that this matrix is 1, 1, 1, 0, 0, 0, 0, 0, 0. This is the 3 by 3 identity matrix. So you'll observe three things. First of all, it's square, so the number of columns has 3 rows and 3 columns. That's the first observation. Secondly, all of the entries on the diagonal, so that is when we take lowercase ij, when I is equal to j, every entry equals 1. And the third property is that every non-1 entry, so every entry that isn't 1 or isn't on the diagonal, is equal to 0. And so the identity has a few important properties. But the most important property that we need to know for now is that if we take any matrix, that is any square matrix, so let's say for example we have a 3 by 3 matrix A, and we multiply uh, I by A or A by I, we always get A. So it's similar to the scalar value 1 when you're multiplying any other scalar or vector by it, in that when you take a square matrix of equal dimension to it, multiplying before or afterwards will give you the same matrix that you multiplied it with. That's all for this tutorial on matrices. If you have any questions, be sure to leave them in the comments below, and please like and subscribe.